Hey, welcome everybody. How's uh how's your week going so far? So you probably have noticed that there's you're missing your module on Canvas. I haven't put it on there. I got good reasons on a couple. I got a couple of reasons. The ones of you that are submitting your stuff via the email, I am putting your grades in, so don't worry. You have done it right. Um, I have people that are missing books and textbooks and lab books and having issues with internet issues and everything else. So um, I have basically pushed back everything um, a week essentially. So that's why you haven't really seen anything because I'm trying to get the best I can to get all the opportunities for everybody to do your stuff. Okay. So that
Thank you.
you're welcome. So that being said, we're going to work on labs tonight. That's going to be all the labs. Well, not all labs. Sorry, 24 through 30, or as far as we get. I mean, there's no rush. Um, and that's one thing with this class. And I see people getting worried because they don't see things popping up. If I'm looking for something, I will come to you and I'll say, "Hey, where's your whatever?" So don't stress out. Uh, but yeah, I've noticed a lot of people are having issues with the software, and this is all new media for all of us. Because typically this lab is held in person on campus, and it makes it a little more it's a little more difficult when you got software. So that's all cool. But I'm going to help you, and we're going to do it together. So um, we started the lab 24 last time, and we were working on that, and I saw some people were working on that. And the first part of it was basically to inspect the motor. Obviously, you can't do that. So we said start at 18 and work your way forward. And the rest of it was just kind of building simple circuits and testing it. So we're going to kind of finish that off today and just kind of finish off 24 and then go into 25 and 26. And when you guys get your feet wet and you feel like you're comfortable, then you guys can go in your own rooms or do whatever you want. So that's all my agenda today is to help you get your labs done and nothing else. Next week we'll have an actual lecture, a new lecture on DC motors. So that'll be riveting, and you guys will enjoy that. I hope. But besides that, it is yeah. I would everything's ready. Everything's ready to be posted and ready to be turned on. I did turn on one thing earlier that was one person's coming in. Um, I did turn on one thing earlier was allowing people to submit whatever files they have done so far. But by no means is that pushing you to get it done right now. So if you see that pop up, it's not like I'm begging for it. Um, People have just been asking where is it at, and the reason it hasn't been turned on is because I'm trying to find a way to um, slow my schedule down so you all are not being overwhelmed for one thing, and two being left in the dust. So, and I don't want anybody kind of left behind and everything else. So we're gonna try to get through this. We'll get this lab done. We'll get this class done. You guys learn everything you need to learn for the class. I'm just gonna have to kind of back off a little bit on my end as far as how much work I'm giving you all because it's a lot, and it's a lot of labs, and it is. So, all right. Well, that being said, is there any questions for me so far? I've gotten a lot of emails, and I haven't got to all of them. I've been answering as many as I can when they come in. From all 7 classes, I got lots of classes, so I'm answering as many as I can and taking care of issues as I get to them. But has anybody? Do you have any questions I can ask directly before?
Yeah.
Yes.
Uh, the video on YouTube, your channel, Joe Noone.
Yeah.
You said you would upload it, and I needed help, and it's still not there.
Which one you looking for? The DC
Uh,
generators?
the one we had last class.
Okay, I'll check that. I might have put it as private. I'm actually streaming there right now, so it should. This is going there. I'm not sure why that didn't go, but I have it. I will send it when we start a lab. I'll go ahead and upload that for you so we can get that done. If it does, well, it might bog my stream down. I'll do it after. But yes, I have the full thing, and I'll put it on Canvas for you. But yeah, I'll do that for you. So um, it's done. It's complete. It's ready. It just I thought it went up. Sorry. Okay. Besides that, great question. Any other
Just something about the PLC class.
Yeah.
When we got put into our breakout rooms,
Yeah.
everybody just left.
Yeah. I saw that. Yeah. So I got to try to figure out another way to do that too. So yeah, we'll figure that out. And that's like today. What I'm gonna do today? I'm gonna try something a little different. I'm gonna keep us all together and do the lab, the first few of them together, and then once we, like I said, get going and everybody feels comfortable, then we'll go off onto our little rooms. And speaking of your all's class, not motors class, PLC class, the software did come, so we'll be I'll be giving you plenty of information here very very soon. So lots of good things, a lot of things go in the background that everybody doesn't see that makes this thing run. But so anyways, okay. So and your suggestion is being taken care of too. We're working on something for just like you asked for the other day. Okay.
Is the lab address always the same? It
Yes.
just the code changes to get in, or is it always the same?
It should be all the same. I have not reset it, and I'm the only
Okay.
administrator, so it should not have changed. Did you need it again?
Yeah, unfortunately, I didn't write it down. I just copied it off the chat and then dropped it in, and then I completely lost it.
Not a problem. Not a problem. Let me
All
get
right.
that for you right now. And because yeah, it does it every so often. The even mine this when I started mine up, it did the same thing. So let me get the chat here, and then I'll drop it in the chat, and then I'll also put in the web address for those who need it. It's open to everybody. It's internet based. So let me switch screens so I can see the web address here. It is it's web access, so it's not like any software you have to download or anything. It's there. So if you guys need access to it, as long as you have internet, which you should because you're here, we'll you should be able to access it. So there we go, and there. Okay, so now that's the web address and the code, and it's the same one. I haven't reset it. I'm the only one that can reset it, so it shouldn't have. I don't know why. Well, I do know the software every so often does refresh, and then it kicks out and wants you to put a new code, the same code in, but just to keep the licenses fresh. That's what it's doing.
That's cool. It's a Word document now, so I'm good to go.
Sounds good. Sounds good.
All right.
All right. Well, let's get to our labs then. Let's see if we can do. So what we're gonna do is if you can go, if you have like multiple screens, or just kind of put me to the side, or just kind of minimize me so I'm in the corner because I'm not really saying anything important. But I'll have the screen up for us to, so we can work on this together. And people are still coming in, so let me check in, Brandon. All right. And let me move my screen around so I can see you all for questions, and also do the screen for my stuff. So my lab, I mean. Okay, there we go. And then you all will be, make sure I do this right. Nope, not that one. That one? There it is. Okay. So that is our the lab for today. And yeah, so basically, I'm just gonna be doing this with you all for the first couple of them, and then I just let me know when you guys are ready, or if you feel comfortable, then I'll put you guys in breakout rooms. Or if you don't want to go to breakout rooms, you want to stay up in the main room, that's fine. Like I said, we're all here together. We're doing this together because if you were in the classroom with me, we'd all be in the same room anyways. So I'm okay with either way. So a few questions have come up about how to. It asks for meters and stuff. So the first page. So I'm referencing the module 24 right now, and that is going to be in the workbook. This is the paperback one. This is starting on page 203. So once you get 203, the first few pages are just kind of talking about the same thing we talked about in the lesson. So you kind of skip over that. And everything up to 18, again, was wanting you to pull out the motor and do your thing. So after that, they actually want you to start building the stuff. So let's start building the one starting on 18. The first thing we're going to do is we need a power supply. This always is in place. So we're going to grab a power supply. And if you don't like doing this every time, you could just like set up something like this and then save it. with your save button here, and then just call this like starting or start or whatever, and then it always has the same module over and over. That's completely up to you. So always drop the power supply, and it's right there. It's 8821. And then the next thing it's going to ask is for us to drop in the DC machine. So the DC machine is going to be up here, and it will be a, not that one. There it is, 8211. So we're going to drop that right next to it. So we got 8211, and then we have our, the power supply. All right, so first thing we're going to do is we got to get our meters. So it's going to ask us to put a bunch of gauges in. Well, this software doesn't have that type of gauges because there's so many different types. It would be hard for them to have all of them. So what they do, there's a module that we don't have on campus, but you can is an option for our lab. We just don't have it. It's called a data acquisition. Let me zoom in a little bit. You can kind of see that a little better. It's a data acquisition, and basically what happens is you just put all the stuff in like you would a meter, but it's going to read out as a digital form when you pull your stuff up top here. That's all that is. So we'll go ahead and zoom out here. Oh, and just for in case you can't see it, the left side, this left column is E, so it's voltage, and the second one is I for current. And that's pretty much all the two you'll ever need. Also, the other thing for this model, it's also going to need 24 volts, and it won't run. You won't get any readings if you don't have that. So we'll go ahead.
Which number is this one?
Well, the interface?
Yes.
That is the 9062 all the way at the bottom.
Thanks.
You're welcome. All right, so the first thing we're going to do is leave power or port number 7, which is our DC, and that is our variable DC, and we're going to move it to a current. So we're going to go to I1. We're going to drop it right in there. And this will be the same thing, and let me kind of go back and forth with my camera here. This will be the same thing as when it goes into that first meter, that A, that's for amperage, right? That's an ammeter, so that's me measuring current. So the first thing we hit is the ammeter, so we're going into this unit, and we got to go out. So ammeters or current measuring devices are always in series. You have to go through them. Voltmeters are in parallel, so you can actually use them as a, they kind of look into it. Now the way I do things, I do the voltage last. That's just the way, when I build my motors and stuff, I just do it last. And you can do it however you want. It doesn't really matter. But it's easier for me if I go through and do it last. And I'll show you why. So I'm going to go ahead and come off the current. And let me drag this away so it doesn't look so messy. All right. And then I'm going to leave number 4 and go back to the negative right below the power supply and drop that right there. Now the next thing is a voltmeter. And it says, that's the guy right here. So it has a V in it, and he's in parallel. And all it's saying is that he wants to be in parallel with the power supply. That's all it's asking for. So we'll do this here. And let me see if I can pop in. There, that's probably a good spot. I'll pop in the corner here, and that way you can kind of see me in the corner of the screen and my other thing as well. Okay, so let's put our voltmeter in. So the voltmeter is going to be this guy here, and we're going to grab this wire and go to the 7, and then this one and go to the in or neutral. It's always better to go from a empty port to a full port. If the software likes it better, I don't know why, but it just does. So I could have, you could start the power supply and go up, but it's going to try to move that piece up, and it doesn't like that. All right, so first thing it says, number 18, so it says connect the figure as in 24.4. We just did that. Check to see the voltage knob is turned all the way to the full counterclockwise position. So we're on 0 right now. Let me move this other way. Okay, so this knob here is all the way over. Turn on the power supply and adjust the voltage until the current is 2.5. Now before we get started, I know I need the 24 volts or I won't see anything. So let me go ahead and grab that and put that right here. Now there's also a 24 volt power supply right here, so we can do that as well. They're both exactly the same, but the one you'll see in the real labs, if you ever get a chance to see them, is right there. But again, the same power supply.
Excuse me.
Yes, sir.
I can't find that data measurement supply. You said 9062.
Yes, sir. 9062. Yep.
Mine is gray. I cannot. Let's see. It does not move to the.
Yours is grayed out.
Yes.
Okay. Typically mine grays out when it's being used, like it is now. But let me see why it would. Is anybody else having that same issue? Anybody else, their things grayed out?
No,
No, everybody's good. Okay.
as far as I know.
So yeah, I can't grab mine. Let me see if I. No, it's not gonna let me drop it there. Okay.
Oh, I just refresh and then now show up.
It's a go. Okay, good, very good.
And
Yeah.
I need to put everything now. Fuck, thank you.
Oh, you're welcome. You're welcome. So we have all this stuff here already hooked up, and so this is the as of figure 24.4. We've hooked up our 24. Again, that's just so the system can see it. And then we're going. It says the first thing is going to number 20. It says turn on a power supply and adjust the voltage to 2.5 amps. All right. So I have to open my instruments up because this guy here is an instrument. So I got to open that up and click on metering. So instruments and then metering, and then you're gonna get this little box. So I'm gonna kind of set this guy to the side a little bit, but he's right there. And then I gotta kind of tell these meters who they are. So I'm gonna click on this little thing. You can click on any of these, but I'm gonna click on the first one, and I want to say that I'm gonna call him voltage. So he's voltage. He's meter 1. We'll call him E1. That's fine. We're gonna be measuring DC, so we're gonna drop it to DC. And I want to make it a digital meter so everybody can see it, and that should be good. And then meter 2 is going to be a current because that's what I'm measuring through there. That's going to be I1. Also digital and DC. Okay, I'm going to say apply. And okay. So now this guy is current and this guy is voltage. Now I'm going to kind of drag him back out of the way. And the last thing I do is these little arrows here. There's two ways to do this. One is click on arrows. This is a single refresh with the red. And the two white ones here are a constant refresh. That's the one you want. You can also click on view, and then you can get the same two options, single and continuous. But let's click on continuous, and that way he's constantly refreshing. And we flick the power per the instructions of number 20. All right, so that goes on there. Let me see if I can put my parts bin away. I click that arrow, everything moves over, so I can make my screen a little bit smaller so I can fit in this meter here. Try to get everything in the same window here. All right, something like that. Okay. So we're going to turn on the little 24 volt power supply. That's going to allow 24 volts to go to this unit here, and we should be able to start turning this meter up. Now I'm getting voltage, but it's saying I'm getting a negative voltage. All right, so let's check out and find out why. Voltage is leaving through I1, so it's giving a negative. Let's see if I can figure out why it went negative on me. Typically in the real labs, that's because it's hooked up backwards. So let's find out why that is.
Maybe you need to change the wires.
Change polarities, that's what I'm thinking
No,
too.
that's ampere. It's the left one. In the left.
Well, yeah, the left one is going to be our voltage, which is E1. Let me click this thing off here. It's telling me don't change them while they're hot, which we shouldn't do in the real life. But okay, I just switched these things around. I'm going to make it right there. I'll make it a digital. There we go. Okay, now we're going the right direction. So I'll do the same thing to the voltage. I'll change the polarity. I'll flip this over here, and that over there. Okay, that should take care of there we go. So now we're both positive. Our voltage and our current is both in the positive range, so we're in good shape. I just hooked it up according to the drawing, but it's apparently didn't like that the way it was. Okay, so it says adjust it until we get to 2.5 amps. So let me go ahead and turn this knob here until I get to 2.5, or as close as we can. You're not going to get perfect on it. Oops. Okay, there you go. 2.563. That's pretty close. All right. The next thing was measure the voltage drop across the series field. That's exactly what the other guy, this guy says 4.35. So number 21 would be 4.3 or 4.35, however. If you want to write that down. So everybody kind of see how that works? Everybody's kind of working. All right, so number 22 is compute the resistance of the series field using the formula. Oh, let me move my camera here to the, there we go, to the bottom, so you can kind of see everything at one time. I didn't realize I was blocking your screen. Okay, so let me do this. Let me go ahead and pull my calculator open. I usually have a iPad hooked to the screen so you can see it as well, but I didn't hook it up tonight. But basically, we're going to do a Ohm's law calculation, saying our voltage divided by our current is going to be our resistance. So our voltage is going to be 4.35. We're going to divide that by 2.56. Okay, and that's going to give us a resistance of 1.699 or 1.7 ohms. All right, so that's number 22 is to be 1.7. The next one is going to be compare the resistance value of the value found in step 10. All right, and that was saying if you would have looked at the motor, you would have saw that the resistor of there was about that. So that's it's showing you the real world and the math should match. Okay. Next one is to return the voltage to 0 and power off, and then connect the next circuit. All right, so that was pretty easy. These first ones are very simple, just basically getting used to the process, and there's nothing really crazy about them, but it does help with getting everything back. Now, I don't want to unhook all these, but I'm going to go ahead and click here, and I'm going to say that I want to remove all wires. I'm going to click on that, and it's going to reset it to a brand new lab, and that's just a really helpful way to not have to unhook everything, every lab. All right, any questions before we move on? So far, everybody's kind of follow along. Is this helping at all?
Yes,
Okay, good.
because I was confused on the voltage part going in and out. I had it flipped backwards.
Gotcha. And it was giving you like a negative?
Yeah, or nothing.
Nothing.
And I couldn't figure out what the hell I was doing wrong.
This whole software has been a learning experience for everybody here. So I'm glad to hear it's helping. That's what I'm here for. All right. So the next one we're going to do is we're going to hook up number 24.5. So that's going to be run on the top of page 208. All right. So I'm going to do the same thing. I got to move mine over. I got a camera in the way. But let me see if I can switch screens real quick. Or switch sides, I should say, with my screen. So I can get everybody in and see what I need to see. And then I'll put me over there. Okay. All right, so the next thing we're going to do is hook up this next one. So we're going to leave number 7 once again. 7 will go into the ammeter. So again, that's number 2. Let's do it the right way. Go back and go to the back side this time. We're going to leave there and go to number 5. So that's going to be our way down here to our shunt circuit. And number 6 will go back into our negative, like that. And then our voltmeter is doing the same thing. It's going to measure right across. We're going to grab the empty socket and head it down here, and do the same there. All right. So we're going to say continuous refresh, which we're already on. We're going to throw the power, and we're going to turn. It says turn up to 0.4 amps. All right, so we're going to barely touch it until it says 0.4. So it's 0.15, 0.16, 0.17.
Yeah, we have to turn it pretty up there.
Oh, is it? Okay.
Yeah, it's almost 3/4 of the way.
Oh, wow. Yeah, okay. Look at that. Huh. Even the real one don't go that far. Okay. So yes, 0.4 on this one here, and that is going to be that's our current, and then we are measuring. Oh, I hooked that backwards. See, I did the one right, but not the other one. If you do this normally, it's going to have a little screen pop up to say "Do not ask again," but it's basically warning you not to do this while it's live. All right, so it says we have 107 volts, so that would be number 27, be 107, and then we're going to do our math for 28. All right, so we do that once again. So we're going to use a voltage of 107. We're going to divide that by our current of 0.404, and that should be a resistance of 264. And your shunt windings are always much higher resistance, but that also makes them more stable. But they're less you're less efficient. I mean less efficient basically. But they are more stable than the other set, the series. But you can see the major difference. That's other one was 1 ohm versus 264 ohms. So big difference in the size of that. Okay, what else we got? That one's there. All right, return power supply to 0, and go to the next one. So again, these are just measuring and making sure that everybody's comfortable with the wiring method. And I'm going to go ahead and remove all plugs and do it again. All right, now it says we're going to do it on number 26, but now we're going to add one more component, and this is going to be the electrodynamometer, so which is another word for a dyno. There is, in the book, it's asking for 2 different versions, but we only have the one, which is going to be the 8960. You grab that, drop it over, like that, and then I'm going to go ahead and minimize my screen again. There we go. And this is going to want 120, but we'll do that in a second. So I'm going to take my 7, go to my ammeter. All right. Well, I guess those are red and black. I just noticed that, which makes sense, hot and negative. Okay. The next one is going to be, we're going to number 1, which is our armature. So we're going from there down to the armature. From the armature, we're going to go back to the power supply. I'm going to pull this up and kind of make it cleaner, a little cleaner at least. Okay. And the next one's going to leave number 8 and go into our number 7. Goes into the number 7. It goes in the ammeter first. Now we're using 2 ammeters in this one here, so I gotta customize that one here in a second.
Can you use different colors?
You can. Yep. Oh, you asked me to? Yes.
If you can use, it's going to be better.
Okay. I sure will. All right. Let me do that. So let's change that to. Oops. Let's make that a blue. Very sensitive. There it is. And all right. And then let's make these a different color as well, so you can kind of see the difference of the wires. As I scroll off it goes away. Make that a yellow. And then this guy here will also be a yellow. Does that help? Is that better?
Yes, thank you.
Oh, you're welcome. Okay. All right, so I'm going to leave the second ammeter, and we're going to go into the number 5, which is at the bottom here. And then we're going to leave with number 6 and go to number 7. And I'll also make that a blue. As soon as my mouse stops running off it. All right, and then we're going to leave number 8 and go back to the power supply. Okay. And the last thing we got to do is we're going to give power to the dyno. And that's going to come in handy here in a little bit, but just so you see it, we're going to hook it up. Number 1, we'll go to the number, it doesn't say it on there, but it looks like 1 on there. And then the neutral would go over to the other guy. And let's make those a different color as well. I guess that probably black didn't work very well, did it? Let's try a. Come on. There it goes. I was making both white. So the white ones are going to be your AC going to the dyno. Your blue ones are going to be your constant DC power supply going up to our second ammeter and then back down, going through our shunt winding and then going through our variable resistor and then going back to the power supply. The this one should be yellow as well. That one there is going to the armature, and he's a variable power supply, variable power source. I'll make that yellow as well, so you see all of them together. Now, because I haven't done this one here, I have to make sure that this meter. All right, let's do something a little different here. So let's make meter. Okay, that is going to be. So the voltmeter of E1, so let's put the current right below it. So I'll make I1, digital, DC, and I'll call this something else. Let's call it, that is going to be the armature. All right, and then we'll make meter 2. All right, that is going to be voltage for E2. All right, and this will be for the armature as well. Oh no, this one here is for the shunt, so the field. Okay, that's digital, DC, E2. Okay, and then right below it should be M8, and that is going to be our current number 2, digital, DC, and this one should also be for your, that's the field also. Try to keep track of where all these are. There we go. So we just did these here. Oop, I didn't call E1. Let me call E1 out real quick. E1, we'll call this armature as well. There we go. So M1 and M7 here on the screen is both the armature. This is the voltage and this is the current. And this is going to be our field voltage and field current. So I kind of separate them there. Now, this one here is not asking for the field quite yet, but I just want to get it set up. But it is asking for the armature. So the armature voltage will be M1, and we have to measure across the armature. So we'll go from the blank right down to the bottom, and then do the same over on this side. And I'll leave those red. So kind of pull it out of the way a little bit. And that's simply just adding the voltage reading for this armature. All right, now that's hooked up, we're going to go through, and it says to turn on the 24-volt power supply. We did that because that also powers the dyno. So we actually got to run power at 24 down here. There we go. Adjust the shunt field rheostat located directly under the DC machine to the full counterclockwise machine direction. So I'll turn this knob right here all the way down. There we go. And the next one is going to be turn on the power supply. That's going to be number 33. So power supply is on. Adjust the electrodynamometer control knob fully to the clockwise position. All right, so that's going to be this guy here. Let me see if I can. So you turn him all the way up. All right. We're supposed to hook these up. I didn't see the belt. If using a prime mover, if necessary, EMS electrodynamometer. They didn't say to put a belt on yet. So, okay. I didn't think we had to, but. All right. The next thing is slowly adjust the voltage knob on the power to the machine begins to turn. So they must need a. If it's loading it down, it must need a belt. So I'm gonna right click on the screen, lower the front panel, right click on this, lower the front panel, click in the middle here and drag and put a belt on. And then I'm going to raise the front panel and then raise the front panel. Nope. There we go. Now we can turn the power back on and then turn that until it barely starts to move. So turn it down again. Okay. So we're barely turning. And let me see here. Okay, that's 35. 36 is measure the amount of current in the armature. So our armature current, because we marked it, it's right here. And that's why when I was telling you earlier, you can set these up. You can also name them. So you go ahead and just give it a name. So I call mine armature and field so I can quickly look and find out what is what. All right, so I got my armature is 0.414 and my volts for the armature is backwards, but it's 6.6. Sorry, yeah, 6.613. Let me put that the right way so I don't confuse anybody. There we go. And never do those hot in the real world. All right. So basically what we did here, we've created this is a DC motor, right? And the DC, which we're doing generators at this point still, but we're doing a DC motor, and we're showing how we're measuring the current of the motor under load for the shunt windings. So that's why we're able to adjust that. So yeah, did anyone else get any other readings than I got on mine? That's about the same. Oop, looks like someone else coming in. Oh, he must have got. Okay. Did you get kicked out again, James?
Yeah, I got kicked out.
It's all good. I didn't see your name till just right now. I looked over. I'm like, oh no. It's all good. The joys of teaching online and learning online, right? Okay, so we did this here. Everything looks good. So I'm gonna go ahead and power this down. Any questions on what we did so far?
Yeah, hold up.
Yeah, sure. Absolutely.
Yeah, I just want to get mine correct before we moved on. I'm just missing one.
Okay.
I just want to see what you have.
Yeah, not a problem. And so, and for later, let's say, this is for everybody, not just you, Richard. But if you guys ever wanted to go through these labs again, like you didn't understand them, I got it recorded on the Zoom and also I'm streaming it right now on the YouTube, on YouTube.
How can we
It's on
find those records?
So the Zoom, you have to go under the Zoom tab, and then you'll find one that says cloud recording,
Okay.
and then you should find it there. And then under YouTube, look under Joe Noone, and then you'll see one that has John Tyler Electrical, has like a windmills and stuff. You'll see or wind generation things. You'll see all that stuff in the.
Okay.
Yeah.
Thank you.
No problem. And I put a lot of things on there that class stuff and that kind of stuff. Because sometimes it's better to watch it the second time when you have time. Just don't rely on that for class time, because you actually this is what you need. The one-on-one is what you need, not the video. So,
All right, I'm good.
You good? Did it work okay?
Yeah.
Cool.
Yeah, it's working fine.
Good.
All right.
All right. So I'm gonna go ahead and power down, and I'm gonna reset. All right. Move all wires, and start over. Okay. So it says. Then after that, it's a bunch of computing. You can do that later if you want. Compute the resistance of the armature. Disconnect the circuit. Okay, so that's 24. 24 is done. At the end of 24, you'll see some review questions. Don't do those now, but I'll have a place on Canvas just for those. So originally I was typing everything up, and I was going to have it basically you just like fill in like a quiz. And I've had people say they don't like that. So I'm going to have it where you just basically write on a piece of paper or type it in a Word doc, and then just attach it or take a picture of it and attach the photo. Either way, whatever works for you best. Just make sure I can read it. I can figure most of it out, but make sure I can read it. But turn those in on the file that says review questions, lab review questions. And the other one should say lab. So if you're ever doing like 24, that's another thing. Let me show you real quick. When you're done with these labs, now you don't have to do it. Well, you probably should do it, but for like this stuff here, like 24 we just did, you basically would save, and then you give it a name, and you would say that this is exercise 24, and then you have your name. So, and that way there it would so like this last one we did is 24-6. So I'd say EX 24-6, and then I'd have my name. Right, and that way there I could find it and then hit save, and then this is the file that you would send to me and attach it to Canvas. And that way there I can pop it in and be like, yep, looks good. And that way so this is my version of be able to watch, look, you know, because if you're in class I'll be walking behind you and checking you guys off as you went through, as your labs went through. But anyways, so if you can turn those in for me, so that should be one assignment should be just for this, to attach these files, and the other one should be for the review questions. So okay, so we're moving on to number 25. Now, with all of these, they have a component that they actually want you to manipulate the real motor. If it has stuff like that, just kind of skip over it because you can't. But the wiring and all that stuff, please go through there. So we'll go through, and we won't have to do, well, we'll hook it up, but let me kind of explain these next two ones. So when you first turn a generator, it has to cut through the residual flux. The residual flux is the magnetic field that is kind of stuck on the pole pieces, the big metal chunks on the outside of the field. It's whatever's left over from the last time it was magnetized. And as the armature spins, that the coils, the windings on the armature cut through that flux and start producing voltage and current. And that is being fed back to its own windings in the field through its brushes, and then it becomes electromagnets. But until that can happen, you need the residual to get that going. So what this whole thing is here is saying, the first lab is saying we're going to put AC on the motor on the field, and we're going to scramble up all those molecules. Right, we're going to get it all scrambled and done, and then so at this point here, if we were to spin it, the generator wouldn't do anything. It's useless. The next thing we have to do is to go through and put DC back on it, and DC realigns everything and makes the electromagnets back in there, and lets us get everything back in place. So we're just gonna hook it up. You can't really do it for real, obviously, but this will allow us to actually go through that motion. So let's go back to the lab real quick, and these are real simple. So basically, the first one's gonna be telling you to go from number 7. Oops, sorry, where are we at here? Number 4. Okay, the first one is removing the residual. So we're going to go from number 4 to, we'll go into the ammeter. Now this ammeter is AC. So actually let me leave it there. I'll just change it. So number 3, and that got stuck. There it goes. Okay. So I went from number 4 into the ammeter and then back out. And because currently this is an AC ammeter, I got to change it to DC, it's DC, I got to change it to AC. So I'm going to click on this and just simply change it to AC.
And you are in page 215?
213. 213, figure 25.-2. All right, and then I'm going to come off number 4 and then go back to neutral. So again, this is wouldn't be something that would be advised, but it would be something that you would have to do if you wanted to demagnetize or remove the residual. So what it would tell you to do is to power up, and then to turn the voltage up until it is at 2.5 amps. So we're gonna turn it up And then when it gets to 2.5, now in the lab, you'd hear this thing hum because you're basically making this thing a giant heater. You're putting AC into a coil, and it's basically making like a stovetop. So you only do it for a second. The thing would hum and buzz and make all kinds of noise, and then you'd bring it back down. Oops. You rotate it back down to 0, and then you'd remove the power. So that would be that lab. And again, you don't have to save this one here. I'm just showing you what you would do and why you would do it. The next one is saying to go to number 7, which is DC, and then do the same thing over here at the bottom. So I'm going to just take those 2 wires and move them. So everything else is exactly the same. And I'll flip this back to a DC meter, right? And I'll go over here and I'll say to put it to 0.4 amps. So I'll turn the power back on and then turn up till it says 0.4. It jumped up quick. All right. So about, well, I'm trying to get as small as I can there. It's very touchy, but you get the idea, right? Just a little bit of current to get that thing back into its to realign everything. Okay.
I found out when you need to tune up that dial, you click over there and then you move your hand like way to the left, then you have more room. You click, hold, and move away, then you have space to. No, you keep yeah.
Yep.
But you move away to have more tune up.
Oh, okay. Okay.
Yeah, but you need to keep clicking. The click needs to hold.
All right, let me see if I can follow you here. Oops. So I'm going to click on the knob, right?
Yes, hold.
Yep.
Goes out or in the top, and then you. Oh no, you need to stay. Yeah. You need to stay on the picture.
Okay. Yeah, I see what you're saying.
You can move better.
Okay. Thank you.
Looks like that.
Yeah. Thank you. And you see what I did when I cranked it up. Let me do it again. I cranked it up, and I actually tripped the breaker. And let me see if I can do it again. So I put 12 amps on there, and you'll see this real red dash popped. That's the artificial circuit breaker saying that there it is. See it?
Oh, that's the circuit break. That's the reason mine is not working. It's red.
Oh, okay. Yeah. You got it has to be black.
Oh, thank you for that.
You click it and it goes back to black. Yep.
Thank you for that.
That just means, in the real one, there's actually a circuit breaker too. So that's kind of something I always look at. But yeah, when it turns red, that trips. And I ran into that earlier, so that's why I'm kind of passing that along. All right. So we're moving through. That's 25-3. So again, don't have to worry about those. I'm just kind of showing you. 25-4. This is on page 215. So it says connect this guy here. So let's go ahead and remove all the stuff once again. And when you guys, if anybody wants to go off and work on your own, let me know and I'll put you guys in a room together. I don't want to bore you. I'm just trying to help. So if you guys get tired of listening to me, then let me know and I'll send you off to a room and you guys can work with whoever you want. But just make sure you get the work done. Don't just take off of me when you get there, because that gets old. Like Garland was saying earlier at the beginning of the class, PLC class, I put everybody in their lockout room, their breakout room, and I went to check on them. They're all gone. I'm like, what in the heck?
So are we supposed to be saving each one of these?
Yes, if you could. Yep. So to go ahead, just hit that little diskette button and just save it at, so it's like figure 25-4 would be 25-4- your name. And then you'd upload that to the canvas. Yep. These first ones are so simple you can build them in a second, so it's not a big deal. The last two I just did. I mean, you're welcome to upload those, but I'm not gonna make you. 25-2 and 25-3. Those are just ones that it's more of a principle than it is a actual function. All right, so we go into the ammeter. We come out of the ammeter, go into number 1. We leave number 2 and go back into the neutral. So we are on AC. So number 1 needs to be a AC again. There we go. And then it says we need a voltmeter, AC voltmeter on the shunt winding 5 and 6. So I'll do the same thing here. I'll grab this and go to 6. Grab this and go to 5. And then I'll tell, who's the E1? So E1 will be, I'll make sure this is also AC. Okay. So now that's hooked up. Turn the power supply on, and this is number 2. Turn the power supply on and adjust the voltage until the current of 0.5 amps flows through the armature. So I'll go ahead and do that. Power supply on. Oops, it was already on. And 0.5. Right about there. Okay. And all right. Open the front cover of the DC machine, which we can't do obviously, and move the brush back and forth. Now, I'm curious if this thing will let me do it. It should be nope, it's not gonna let me do it. So right here, typically there is a knob that you on the machine that you actually physically grab that you can drag back and forth. And what you're doing, you remember back in the lesson, and I'm going to upload that video, like I was telling Jose earlier, but that the neutral plane. I'm sorry, I'm trying to do two things at once. Let me get back here. So the neutral plane is basically where the perfect line is when you're cutting the flux. Now, we talk about that in the thing, and I'm uploading the video to Canvas and YouTube so you guys can see that as one whole lesson. But if the neutral plane, if the brush is in the right spot, it's going to cut a perfect set of flux lines. This whole lab here is saying that when you put a load on a motor, those flux lines get twisted, and you got to set the neutral plane. And what this whole thing is basically moving the brush back and forth, and you actually watch your voltmeter move back and forth. Obviously, you can't do that. So this one here is another one that we can't participate in. But again, I'm just hooking it up to show you. So you don't have to save this one here, unless you want to. But I will. Anyways, just showing you that. Okay. So next thing is the number 216 is the review question. So that one's now done. So we're going to exercise 26. 26. This is for series generators. So now we're actually going to do something. All right, so you can read all through the procedure if you'd like. So basically it's explaining how these things are hooked up and why they do what they do. But we're going to start on figure 26-3. So for that, it looks like it's starting that on, try to find the question number. 26.2. There it is. Okay. So number 3, this is on page 219. Connect the circuit shown in figure 26.3 if the synchronous machine is being used, which we will be. The prime mover, as a prime mover, we won't need that. Okay. Anyways, if the DC machine is not used, open the on-off switch for the synchronous machine. Okay. So what we're going to do now, I was reading through that real quick as we go to the next lab. We take all my wires off here. So what it was saying, that whole thing was saying that I need to I'm going to change out my machine here. So I'm going to try to find the synchronous machine, which is going to be the AC motor. And right here. Okay. So make sure I don't nope, should be the only one. So I'm going to go ahead and grab this guy. I'm going to the prime mover. I'm going to right click and say I want to delete this module. And then I'm going to come back over here, grab my synchronous motor, which is 8241, and then drag that over to the other side. All right, then I can close my little thing there. All right, so this one here is a lot easier to set up and wire, so I'm just going to use this one here as an example. but the lab would have worked either way. But I just wanted to show you this way as well. Okay, so the first thing we're going to do is hook up our meters. So we're going to need all 3 ammeters. So let's go ahead and set these things up real quick so we can make it nice and easy for us. So the first one, let me click on my page here again. So M1, let's make that into a current meter. That's going to be I digital, and this will be AC, so that one's right. And just for example, I'm going to call it A phase. You'll see why. Okay. It's going to be motor 2 or meter 2. I'm going to also be current. This will be I2. And I'll say B phase. And this is just for me for example. You don't have to do this if you want. I'm just showing you so you kind of don't get confused when I'm showing you this stuff. All right, I'm going to go to M3. Oops. I want to go current, go to I3, and then we'll call this C phase. All right. I'm going to go to number 7, which is right below. And it looks like I'm going to need 1, 2, all right, 2 voltmeters in the next example. So let me get those ready. So I'm going to call this the voltmeter E1 digital. I'll leave it like that, E1. And then number 8 will also be, make that voltage, and that's E2. Okay? And I'm going to say OK. So now I have A, B, and C phase, and I wrote these out so you can kind of see where everything's going. And then I have my 2 meters here, E1 and E2, which we'll use here in a minute. All right, the first thing we're going to do is we're going to leave number 1 and go into the ammeter. So on here, I'm going to come over top to make it easier, and I will change the colors for you so you can kind of see each one. We'll leave here, and this will go down to the first set of windings. Okay, so I'll make that red. The next one will go in here. I'll pull it all the way. Let's give that a color of blue. All right, I'm going to leave here and go to the next winding. Okay, I'll also make that one blue as well. And this last one here, I'll go in there. Ooh, where'd it go? Okay. Right click on it. Let's make that, let's make it yellow. Why not? Go to the bottom one here. This will also be yellow, so you can kind of see the phases. And I'll explain how these motors work later when we get to the AC 3-phase, and then we get into synchronous motors. Because it'll make a lot more sense. Me explaining now would not do any justice for you right now. All right, last thing I do, I got to short these together. So I'm going to run a wire from there to there. I'm going to pull that out of the way. And I'm going to do one from there to there. And I'll do the same thing. And these are just basically jumpers. Here, I didn't know I could do that. There you go. Well, that was better. All right, so these are just simple jumpers that go on the bottom. And the last thing we have to hook up is the DC for our the magnet inside. So I'll leave number 8. Go to the red. Leave here. Okay. So that one there is basically turning on internal magnet on. Let me go ahead and I don't know why that motor's running. Let's turn that off. Nothing hooked to it, so it shouldn't. Lower the front panel. it's very confused. It's all right. We're going to lower the front panel on this one here. We're going to drag one from the other. All right, one of these needs to stop. Let's try this one here, stop motor. This is one confused little motor. All right. There we go. I got it. All right. I'm going to grab the belt and put it on there. There we go. I don't know why it was taking so long to do that. Close the front panels. All right. So now we're hooked up. Everything's ready on this side, at least, is ready. And what we've basically just created is a 3-phase synchronous AC motor. That is not the lab. That is just a part of this, but I'll have to explain it here in a second. This is going to be our power source, our mechanical power source to turn our generator. So again, for the first time, we're actually creating a generator. So this part would complete 26-3. So that lab would be done now. But we're going to leave this lab together and go on to the next one because it requires this one to get to this guy. So this one here, it says, well, we need a resistive load. So let me get a resistive load, and I will put it right there. I wonder if I can move this over. Yeah, that might help. Okay. I'll move everything over. I'll put this away. There we go. There we go. And I'll pull these up out of the way once again because we're going to be using that module right there at the bottom. All right. So again, the first lab here was the power source. This one here is going to be the actual motor or the generator. So the first thing we're going to do is we're going to come off of our first resistor bank, and it says this is on 26-5. We're going to go into the ammeter, DC ammeter. We're going to do that. It's asking for an ammeter, but we're out of ammeters. So let me see what I can do here. Let me see if I can change one of these voltmeters to an ammeter. See if that would help me. Because, oh, maybe I need another module. Maybe that's what it's asking me to do. Nope. Okay, can't do that. So typically, you would have another analog module you'd be able to plug into, but let's see what I can figure out. All right, so let's do this. Let me go ahead and I'll take this wire here out, the 3-phase, C phase, and we'll take that out because basically what it was doing, it was showing you current, but you'll see that current through the first two. So I'm going to...
You can use the yellow and the red at the top. The measurements. Ohmmeter.
Oh, you are right. The actual, you are right.
You can use that.
I forgot about those.
We have 2 extra.
Yeah, great point. Thank you. Yeah, I forgot we had 2 handheld ones up top. All right, which is normally the first thing I grab is my meter. I'm so used to using this thing here now, or the the software. All right, let's go ahead and grab one of these and bring it. Oops, there it is. He likes staying up top. I don't know why, but okay. So we're going to change that to current. So it's amps. All right, now we can complete our thing. So we're going to go out of the resistor bank into the A for amperage. All right, we're going to come out the common, and we'll go down to number 4. So we're going to follow. This is 26-5. So I'll grab this and go all the way down to number 4, like that. And let's give him a different color so you don't confuse anybody. Let's make it well, not that, 'cause it's the same color. There we go. Almost there. There we go. Okay. So those two are now power is coming, or the load is right there. Then I'm gonna do it from.
You can drag it. You can drag the omnimeter. He goes everywhere we want.
Oh.
You can drag.
Oh, it will move. Okay. It kept snapping back on me.
Okay.
There we go. Okay, cool. Yeah, I don't know why it was doing that. Let me see if I can get this on. There we go. I'll get it in the front. Yeah, every time I let go of it, it snapped back in the top corner. Well, that's nice. Thank you. All right, so I'll put that right there. All right, and okay, so that is on number 1. Number 2, we'll go back to the load. So let's go back up here to this guy, just like that. Drag out of the way. Also make that the same color so you can kind of see the path. And I'll do the same thing here. Okay, and then the last thing we gotta do is jump across these and then put our voltmeter in. So I'll go from the empty slot to the empty slot and do that. And then do the, there you go, let go. And then I'll go from here. It's doing that thing where it grabs it. Okay. So I'll put that there. And there. I'm basically just jumping across top. I'm going to do the same in the bottom. So I'm going to go from there to there. And then do this from there to there. Like that. That's all I'm doing. I'm doing a basic, I'm making a parallel circuit. Okay. And then the last thing we're going to do is do our the voltage drop across these points here. So we have, move this other way. We got this wire right here. We'll click on there. This is the voltmeter. This is DC voltmeter, 20 volt range, 26-5. This will go at the bottom. And I'll make these different color too, so you can see those are for the meter. All right. So what this circuit is doing, let me kind of zoom out slightly so you kind of see everything. It's getting a little big now. My AC power, this is my variable AC power in the slot 1, and this is sending 3 phases up over to the ammeters. The ammeters are measuring the current. What we did here, phase A, phase B, and phase C. Then we're going to go down to the actual motor. This is an AC synchronous 3-phase motor. And then we're going to jump the other 3 together. And then these are our DC magnets, which make it a synchronous motor. We'll talk about that in the few chapters ahead. So this part here is basically nothing more than just the turning force. This is the mechanical energy. So this whole lab is based on this guy right here. What we just did is when this armature spins, he's going to cut the flux, and that's going to produce voltage, and that voltage is going to be measured through the current, the current's be measured, but we're going to be using the resistance here as a load. So, all right. So this will be, let me see where this will go. So 26-5, okay. Connect the circuit shown in 26.5. Do not disconnect the synchronous machine, okay. So that was the mistake everybody makes. Everybody always disconnects this machine and before they hook this one up. Turn on the power supply and close the S switch. S switch is right here next to your knob of the prime mover, okay. So we'll go ahead and turn our power on. Everything starts rotating. We see we're getting some currents here. I'm gonna go ahead and turn on the exciter switch. Right. So everything, what happened there is there's an internal magnet. The internal magnet locked in with the the rotating magnetic field on the outside of the motor. Again, we'll explain this whole magic box over here later. But this basically went from surging in the labs. You heard this thing like surging up and down, up and down. As soon as you flick that, it would be nice and quiet. So if you kind of look at your numbers over here, I just turned the switch off. This is called asynchronous. So this motor is surging up and down and up and down. And it's going to make a heck of a bunch of noise. As soon as I flick that switch, everything locks in. My current drops dramatically, and it is now running very efficiently. So that whole thing is just to make this thing stable. It's spinning right now at 1,800 RPMs, and I think there is a tack in here, but I'm not going to do it. But if you want to play with that, there should be a tachometer somewhere. I'll have to find it. Okay. So now that's running there. So the next thing it says, so we threw the switch, measure the amount of current flow from the DC generator to the variable resistance module. Okay, that's going to be this guy right here. So he's showing 0, and the reason he's showing 0 because nothing's turned on. All paths are this is like a light switch when they're all down. So if I was to turn one of these up, you would start seeing current flow, right? But because there is no path currently, you should see 0, or because there's nothing to flow. We're going to measure the voltage being applied. So our voltage will be the one up here. This would be a 9.235, and that is going to be how much voltage this is currently creating right now. So about 9 volts. All right, so that's number 10. All right, so number 11, it says, I want you to make it to 171 0.4 ohms. So that means I got to close the first 3. But just because I've done this 100 times, if you ever want to see this chart, you can go to the back. There's one in this chapter, but also in the very back of your textbook on page 379, there is a chart for you, and that chart is just for this resistance module. So there's 4 columns. The first column to your far left is going to be the ohmic value, how many ohms you want. The second one is called the first section. That is basically your first section of resistors, the one I'm circling right now. The second is the second. Obviously, the third is the third, right? So in ours, it says in order for us to get to 171.4, we're going to need all of the first ones closed, which I did, and then none of the other ones. So none and none. That's how we got that current. So if you want to know how I got to that level, that is how. All right. Now I'm showing negative here because so I got to, let me see if I can reconnect this to get a positive. It doesn't matter. It's gonna show regardless the right, but I want to show you guys the right polarity. Okay, so 0.065 amps. All right, and make sure I don't miss anything else. 1,800 RPMs. So everything else should be straight. Okay. All right. So now we're going to measure. So we just said that it was 0.65. That's number 12. We're going to measure the amount of DC voltage being applied to the variable resistance module. We said that earlier. That was 11.29. The voltage went up. We started producing more. The reason we're producing more is because we're producing current now, and the current is now magnetizing. So the 6 volts was just from the residual. Now we're actually pushing current through those electromagnets. Number 14, close the switch. Switch is necessary to make 85.7. So that's going to be the first and the second module all up. And you're going to see that you're going to measure the amount of DC at the load. So we are now measuring 0.168. And we're measuring the voltage. The voltage is now 14 volts. We're going to do the same thing with 57.1. 57.1 is going to be, I got to look this up because I already forget, it's all of them. So they all go up. There, there, and there. Okay? So all these, oh, the next question is, the amperage is 0.343. Let's try to figure out why everything stopped all of a sudden. 0.343, and the voltage is 19.61. So that took care of all the way to 19. It says open all switches on the variable resistance module and turn off the power supply. So basically put everything back to the original. And start over. All right, does that help so far? Was that making sense what I'm saying or what I'm going through? Anybody need any further?
I got like 0 amps when I closed all of the switches on the resist or on the load.
Okay. So when you close, when you pushed all of them up?
Yeah.
Okay. So your AC motor is spinning, the belt's on. We have the wires connected like this from the ammeter through the series winding up through number 1 and then leaving on 2 and then branches like this.
Yeah. Let me they're not spinning anymore. Let me try something.
Okay.
And I'm not spinning at all.
Okay. So your power supply is up?
Yeah.
Okay.
Check the breaker.
Well, I checked the breaker, but that usually is only for if you overload it. But at this point we should, make sure that's not red. So nothing's spinning at all right now?
Yeah, it was spinning, but when I closed all the switches, it shut it off.
Interesting.
Can I cast it to you?
Yeah, absolutely. Go ahead and share if you want. Yeah. Okay.
Can you see it?
Yep, I see it. Yep. Oop, sorry, walk with microphone. Yeah, I see it. All right, that's right. It looks right. All right, so your voltmeter's hooked up. Your jumpered across. You're good there. It's on amps. All right, let's check all right, lights are on for 3-phase. I'm just going through your circuit to see if everything looks right. Everything looks good. Try to, I don't know if you can see on mine, but there's and this is only because on the real ones it does this, but this exciter switch, try to turn that off and see if that changes anything. Okay.
Oh, there we go.
And then turn it back on. Okay, everything should lock back in. In the real lab, one thing it tells you, don't start it with that on because it makes a horrible noise. Because you're trying to start a spinning motor. The rotating field is going much faster than the internal armature, and it's not up to speed, and it tells you don't lock that in because it sounds like a Mack truck trying to stop.
Okay, so should I leave it on because the amperage is dropping?
Yes. Yeah, why is it dropping like that? That's a good question. Oh, wait. Your exciter knob. Oh, turn your exciter knob all the way to the counterclockwise position. There you go. Now turn that knob off again, that switch. All right, now go ahead and flick it on, and it should. Is it pulling down again?
Yeah.
Is it stabilizing? 3.
I still have these three on. Is that
And we do the
is
same
that right?
thing. I'll do the same thing you're doing. Make sure. So I got. Mine's turned all the way off. Exciter's on. Yeah, I got 0.65. You got 0.322. You're just slowing down. Wow. Huh. Oh,
The Rios
what? Go ahead.
the rheostat should be max, right?
Yeah, but nothing's hooked up to
That's
that.
being driven, right? Yeah.
Yeah. Huh. It definitely doesn't like your that exciter switch being on though.
No.
It's DC. Everything's wired up right. I mean, I'm looking at it, everything's wired normal.
Should the voltage be all the way up?
No, well, see, the we're plugged into the constant, so that this whole thing is out of play. Like that gauge.
Oh, okay.
Yeah,
That's
gauge
right.
is nothing.
It's already at 120.
Yeah, it's already at 120. It's line voltage. So why is yours slowing down? That's a good question. All right. So exciter's all the way off. Mine switches up. It stabilizes at 0.065. Huh. That is weird. But you turn the exciter off, it starts up again. So it's basically saying the current is so high, or the load is so high that it can't turn. But
These three are supposed to be on, right?
Yes.
The first three?
Yep. Is everybody else's working? Anybody else having a similar problem?
I'm good.
Yeah, I mean you're wired up. You're wired up fine. I'm not sure why that's doing that, but it's definitely an issue because it's not even. I can see it slowing down. Yeah, because your purple wires, those are going to your DC power supply, which is constant. Your exciter is turned on. The knob is all the way counterclockwise. Jumpers are right. Power is right. Going into the meter, going out, going to 1, 2, and 3. Yeah, I don't see anything on the wiring side that's wrong. Huh. Well, I mean, you can, yeah, I would just save what you have and I'll take that because that's weird.
This is 26.3, right?
26.3. Make sure. 26.5. So 26-3 was the AC motor, and 26.5 is the other one. So I would just save it as 26.5.
Okay.
Or either one. I mean, I know what the difference is. Cool. All right. So we'll go to the next one here. You just click on stop sharing when you're ready, and it'll drop it out. There it goes. Okay. What else we got? Okay, so we're on 27. All right, does anybody need to take a break or anything? Everybody just want to take a little stretch? Everybody's good?
All of this is being recorded, right? Because
yes.
I can't access my lab until after class.
Yeah, it's all recorded and it's on YouTube as well. And Jeff wants to take a break, so let's take 10 minutes. Let's come back about 7:35, and we'll go on and try to knock out 27, 28, 29, and 30 if we can. Or not, we'll just get as far as we can. I'm shooting for about 8:30, 8:45. I think it's a good, at least together portion. I'd say that's probably good. By that time, you hopefully should have a good understanding of the labs. And then, of course, you want more time, just let me know. But at that point, and then, of course, I told you I push everything back, so you have more than enough time, I hope, to get all this stuff done. And all the books hopefully will come in, lab books, and it's been a heck of a few weeks. So I haven't forgot about you guys out there. Just a lot going on back here.
Did you want us to turn in these lab pages as well as the actual lab?
Yeah, so on Canvas, and I'll get those posted. I turn one on. I'll turn the other one on after class. One will be nothing but these files here, saving these and uploading all of them. So it'll say be 20, 24, 25, 26, 27, 28, 23. Those will be uploaded to one file, and the other one will be all the review questions. So
okay, just the review questions at the back.
Yep.
Of the actual thing. Okay.
Yeah. At the end of every exercise, there's a set of review questions. Like page 222 has 5 questions, so you can type them up on a Google Doc or Word doc, or you can write them in your book and take a picture, however you want to do it. And so.
What chapter in the other book can we find to answer those questions?
Unit 30. So it's going to be on page. Let me pull it up real quick. Oops. It is going to start on.
It's the same chapter as last week, right?
Yes, sir. Yep.
Okay.
727. So it'll be on page 727. Yes, and I will be also putting that lesson online. I know Richard asked for it. I got someone else asked for it. So, yep. We'll make sure to get it online for you guys. So just because I know this stuff is just kind of, it's hard to concentrate with these videos. I know. I get it. I'm not trying to be too hard on everybody. So, all right, let's take a break. And let's come back. Well, I used up some of your breaks. Let's come back at 7:40 now.
Okay.
Yep. All right. Take care. I'll see you in a little bit.
Mm-hmm.
All right, welcome back. Everybody back here. You got a few more minutes. I give you guys an extra 2 or 3 to get going. All right, let's get knock a couple more labs out here and see if we can get all the way to 30 tonight. If not, it's fine. We'll work on it next week. Or, I mean, we'll start the next lesson next week. You'll turn that stuff in next week.
But we are going to have time to turn to you, right?
Yes. Yep. So, you mean for the stuff the time to turn in?
Yes.
Yeah. So I pushed everything back a week. So it's, I think, I'll look at it. I think it's somewhere 16th, 15th, about that. It's yeah.
Okay, because I try to pay attention. Maybe at the lab I could do everything, but not over here.
Yeah. No, and that's the problem we're running into because the virtual thing. So that's why I'm kind of laxing and pushing back.
No.
Yeah.
It's because I have a lot more experience than the others.
Yeah. No,
You see?
It's all good.
A lot more experience. White hair.
Yep. So, all right, we'll get on this next one and see if we can lock it up and get this thing done. All right, let's go to. Let me see if I can. Yes.
So far, for the module you just opened up, those were for the labs we did last week, right?
No, last week and this week. So this is this week's assignment. But this week, this here was due or was going to be due this coming Wednesday, and now it's going to be due next week. So 2 weeks from now.
Okay, so the ones we did last week, the 3 we did last week, we turned them into the one you just opened today.
Yes. Yep. Well, this is all. So each module I open, so I'll say like DC generators, which is the one we're doing now, that lasts for 2 weeks. So that's why you're not seeing them pop up every week. It's a 2-week span. So I had it up and then I pulled it down, and then I fixed it and I brought it back up. So anyways, So now it's back up with one module open just for that one thing, and I'll have more open. But that's for all of these. That's for what we talked about last week. That's for all this stuff here this week. So it all goes to those files there. And if I miss anything, just let me know and I'll make sure I open it. But yeah. So
okay.
I'm sorry.
So far, the only ones we've done today for this class is 26-3 that we need to save.
Yes, 26-3 was the big one. Yeah, 26-3 or 26-5, you can call it either one. That was the big one, yes. That was the only one that I'm really looking for today.
And we're going to be doing more in a few minutes, right?
Yes, we're doing 27, 28, and 29. So the first ones were more just how to get used to the building the modules. And you can turn those in or not. But the ones I need to be like 26 and 27.
Okay.
28. So yeah, yeah, and then because they are much more
advanced.
Yeah, and the first one just 2 wires and whatever. So like in the labs, it would have made a lot more sense because you actually hear the thing humming and you can make the adjustments accordingly.
So just to be safe, I just suggest turn in every single lab we did last week and the ones we'll be doing today, right?
Correct. Yep. Put them
Okay.
all
All right.
on there, and there should be 2 assignments open. One's going to be just all this software stuff, so all these files, and the other one is going to be just for the review questions from each unit. And I do need those from 24 all the way to 30 before next week.
Okay, but we turn the questions in under the labs, right?
Yes. Yep.
Okay.
Yep.
All
Well,
right.
It'll say lab review questions. It'll say it on the module when it opens this afternoon or this evening.
Oh, okay.
Yeah,
Okay. All right.
like I said, I had it up and then I had to pull it down and then I make adjustments. So yeah, I'll fix what needs to be fixed and I'll put it back up and you'll be able to put that. But it should say one will say files and it should say do not put review questions here, and the other one will say review questions, lab review
Okay, because
questions.
this one says electrical 159, unit 30, DC generators, virtual motors labs.
Yep.
But you haven't put up the questions, right?
I have not. Yep.
Okay.
Correct. Yep. That's the one that's I'm putting up this
All right.
evening.
I get it. Thank you.
No problem.
Right. Okay. Thank you.
No problem. All right, switching over to there we go. Got to make sure I got the right screen. So, yep, let's start on 27. So let me go ahead and erase all this. We'll see if we get these 2 knocked out fairly quickly. Now, this next one here pretty much uses the same AC drive. So for simplicity, I'm going to kind of leave it alone. If you've already undone it, it's fine. But we're going to rebuild it back the way it was. And the only thing we're going to change is the connections. So everything is exactly the same, except for we're going to make a few changes on the generator. So just to kind of speed things up a little bit, we're not going to rebuild the entire thing because it is exactly the same wiring for the most part. All right, so let me go ahead and shut this thing off. Let it power down. And let's make our adjustments or changes. So this one here is going to, we still got the same ammeter, so we're still using the same one. I don't know why this guy's still spinning. Let's stop the motor. There we go. We still got our same voltmeter, so that's all the same. So the only thing that is changing, let me get rid of this here, is the wire coming from the multimeter is going to 1, and the wire that is going to the load, yep, it's already there. So, excuse me. That's the only thing that changed on that one there. So this is on figure 27-4. I'm looking at the resistors, which is the resistor bank here. You should have the 3 jump together, the 3 jump together. There should be a DC voltmeter that says 200 volt range. That's going to be the green wires here. Those from the last one. And then we have our ammeter, which we're using the multimeter for. So before we went down to the series winding, but we're not doing that for this particular one. This will be a different module. So, but we are hooking it directly to the armature, just like that. We're loading the armature. Now this one here has something different where it's going to require us to have power to the actual shunt. So I'm going to zoom in here and see which number 7. Yep, 7's up top. So we're going to say it's asking for 7 to go into another amp meter. So we're going to try to pull another one down here. Put it somewhere that's not going to be confusing. I'll pop it right there. All right, this will be the other amp meter. So this amp meter here, the red one, is going to be nothing but the armature, and this will be for the field. All right, so we're going to leave number 7, which would be right here. We're going to go into our ammeter, so we're going to go into the A, and we're going to leave the ammeter and go down to our number 5 coil, which is your shunt. And then we'll do the same thing. We're going to leave here and then go back to our power supply. So we kind of pull that out of the way, and then I'll zoom back out so you kind of see the whole thing. And let me change these colors so they're more visible. All right, and then we will zoom out here. All right, so again, everything's exactly the same. So if you didn't tear the last one apart, it would probably save you a lot of time. But if you did, just rebuild it the way we had before. So the 3 phases go to the ammeters. The ammeters then power to 1, 2, and 3 on the synchronous AC motor. You jump these together. You put your synchronous power here, these wires here for 7 and 8 for your the synchronous motor. And then we have our bus resistor load here is wired together. Move this a little bit. These are just in parallel, so you just wire these in parallel, jumping them with each side is measuring the voltmeter. And then the thing we added last time was we've had a voltmeter originally was going to the series winding and then going up to the armature. In this case, we have taken the series completely out and we're powering the shunt separately. So this is called a separately excited shunt motor. And now we're using this guy, the yellow, as our shunt, our field amperage, and this will be our armature amperage. All right, let's power it up and see what we got. So it says connect 27-4, do not disconnect the synchronous machine, okay? Turn on the power supply, close switch S1, so we're going to turn the power supply back on. We're going to close S1, okay, so we're locking at 1800 RPMs. Adjust the front knob on the front of the synchronous machine until the 3 AC indicators indicate the lowest value. So I'll turn this here until we get the lowest reading on the meters up top. This is the green meters, phase A, phase B, and phase C. All right, so that goes up. So let's go here. Try and get it just right. That's going up again. All right. So it looks like
we are doing 27.3, right?
We're doing 27.4. Yep.
27.4.
Yep.
Okay.
Which is 27.3 should be the 27.3 is the AC motor, the power source.
Okay.
All right, let me try this again. It looks like I did the same thing that Walters was doing earlier. All right, motor's on. Turn the synchronous switch, should lock in there. All right, there we go. All right, 3.6, 3.2, that's better. So what I'm doing in my meters, I'm trying to see the lowest value I can get. Oops, going back up. So right about there. Okay, so 0.69, that's about as low as current as I can get on my 3 phases. That's the ones here in the box. All right, so that takes care of number 9. All right, so record the value of the output voltage and the amount of shunt field current for the DC machine. All right, so this one here, we're not getting anything yet because I have nothing turned on. So we're going to go ahead and adjust the control knob to the front of the synchronous motor. We did that already. Okay, record the value of the output. Record the value of the output voltage and the amount of shunt current from the DC machine. So currently is 0 because nothing is. Okay, yep. So right now everything is 0 because of now our armature. We're having a 0.05 amps, but our actual field windings have nothing because they're not excited yet. It's still self-excited or still residual. And you can see here we're using it's creating 8.66 volts. So it'll be number 10 will be 8.66 volts with a field current of 0. Okay, increase the shunt field current by increasing the DC voltage applied to it, and this can be adjusted. This is number 11. This can be adjusted by the control knob. Control it to 80 volts. All right, so we're going to turn this up. Now I'm going to let me zoom in here so I can see where 80 is. All right, so I'm looking at this gauge here. I'm going to turn this thing until it says 7 and in, right there. So there's 50. There's about 80 right about there. Okay, I'm going to zoom back out. Try to get all my stuff back in there. There we go. All right, so try to get this thing spinning again. Okay, so now we have we're producing our AC motor, our AC drive is pulling 0.5 amps, so half an amp per phase, where our generator is now producing 131 volts. So now that we've turned this up to 80 volts, our field current is now 0.329. So number 11 would be 0.329 there. Increase the shunt current into the output voltage is 120. So we're going to crank it up to 120. And then we're going to measure it again, and we're going to see that it's 0.526. So the only thing we're doing now is we're turning the DC up, and the DC is making the field current stronger, which is making a stronger magnetic field, which is letting us produce more voltage. Okay. That takes care of 13. So 0.526 is 13. And then fill in the chart at the next chart in 27.5. So the chart says we have there's 4 columns. The far left is your resistance, then it's the output voltage, the output current, and then the AC amps. So with infinity is completely open. So everything is completely open, which is what it is now. So our output voltage right now is going to be 165 volts. So that's going to be the output voltage. This is under infinity. I'm going from left to right. The amps will be 0 because there's no There is no current flow. And the AC amps, as far as the draw, that's the last one, that is going to be 0.192. That's how much the actual motor is struggling to turn this thing. It's using 0.19 amps. All right, we'll go to the next one, which is 1200. So let me get to my chart again. So 1200 is going to be just the 1200 with just this one resistor up here. Click on that. All right, so output voltage now is going to be 163.8. The output current is going to be now 0.136, and the AC amps is going to be 0.256. That's going to be how much the motor is working to get this thing turning. All right, the next is 600. So I'm going to open the 1200, close the 600, and now we are pulling output voltage of 162.4. We have a output current of a 0.27, and then our motor is at 0.32 amps. All right, we're on number 400 now. So I'm going to go ahead and close the 600, or open the 600, close the 400. The 400 will be the 1200 and 600 together. All right, so 12 and 6 will be turned on. All right, so now we have a voltage of 160.9. We have a current of 0.402. And we have an AC amps of 0.384. All right, we'll do number 300. So 300 would just be the 300. So we'll open these two. Open that one. There goes that one and that one. Now open 300. And this will now be, all right, so now we're now producing 159.4 volts. This is the 300 row now. 0.531 amps we're producing, producing. We're using 0.448 amps for the motor. That's how hard the motor is struggling to turn. Next one is 240, so it's a 12 and a 3, so I'll turn the 12 on. All right, so we're producing our voltage. This is the 240 column. 240 is 157.9. The output current is 0.657, and our motor is struggling at 0.512. All right, and the next one is 150. So 150 is going to be everything on the first row, so on, and then the 1200 from the second. All right, we're producing 153 volts. We have 1.02 amps we're using or creating, and then our motor is at 0.69, 0.7 amps. Everybody follow along so far? Am I losing anybody?
So far, so good.
Okay, good. Thank you. All right, let me turn all these off here. So this next one will be the 300 in the first column. That we're at 100 ohms. So 300 in the first column, 300 in the second column, and 300 in the third column. All right, so now we are producing 146.4 volts. We have 1.464 amps of output, and the motor is using 0.941 amps. We're doing 80, so 80 is the next one down. That is everything in the first, everything in the second, and the 1200. So I'll turn everything in the first, everything in the second, and then just the 1200 on the third. Yep. I'll turn the 300 off. There we go. So our voltage being produced is 141.5. Current is 1.768, and our motor is using 1.118. And our last one is everything on. So turn the rest of these on. And this will be 57.1. So our output voltage is 132. Our output current is going to be 2.31. And our motor is using 1.48. All right, so that should fill that whole chart in. And then you should be able to graph that. And that should be able to help you answer some more questions coming up. And then the review questions. So now we're on to 28. All right, is everybody still with me so far? All right, so now we're going to 28. 28, the motor is exactly the same, so I'm not going to disconnect anything. The generator is slightly different, so I'm over on page 234 now, 28.4, and we're just going to do some reconfiguring, but everything's pretty much the same. All right, so we know the AC motor is the same. We're going to leave that alone. That's a nice thing about doing these back to back is you can leave these labs up. Okay, so I'm going from left to right on my image, 28.4. So I'm going to start at the resistor bank that looks the same. We go into our ammeter, which is our red ammeter. Let me turn this motor off. I don't know why it's running. There we go.
The bank you said was in the back of the book on page.
Oh yes, page 379.
Okay.
We got the meter here. This is going to be for our amps. And okay, so this is from here. We'll go to number 1, which we already are, and 2 we'll go back. Okay, so now instead of 2 going back to the load, let me grab just that one. Let's see if it lets me do it. All right, so I'm going to take this and go to number 8. Shorten this up. Put that back where it was. Okay. Number 7, we'll go to another ammeter, which we don't have. So we need to get that. Actually, let me see here. That's the load. Oh, I can use this one here. I sure can. Okay. Because we're not separately excited, no more self-excited. So I can use these. Okay, so from here, I'll take this guy and put him on number 1. Make sure I'm doing this right here. Yep, 1. Actually, let me see if I can move some wires around real quick. Okay, there's 6. 6 is going to, oh, I see. Okay, let me take that off then. Delete that. So we leave here. This is number 2, port 2. We're going to go down to number 8, which is our rheostat. From 8, we'll go to our meter. So go into the ammeter. That's where this guy was supposed to go. Okay, I'll move him. The common will come and go to 6, which will be over here. Just like that. And then 5 will go back into number 1. So I'll take 5. 5 and go to 1. I'll make it the same color so it matches. So you can follow along. All right. So everything's exactly the same. We're leaving. We'll start here. We're leaving number 2. 2 goes down to number 8. 8 is going to the rheostat. We leave number 8 and go to our, in the book it says DC ammeter, 0.5 ammeter range. All right, we don't have that gauge, but we're going to send it up to this ammeter. We're going to come out of the common, go back down to number 6. So technically this actually could be like right there if you wanted to look the same. But you get the idea. Okay. And we leave... we come out of number 5, and then 5 jumps to number 1. And this one tricks everybody. Between 5 and 1, you see that wire, and it jumps over the other wire going to the resistor. But look, it has like a little bump in it or hump. It's actually jumping over it. It's not actually connected to it. So if anybody gets confused in that part, that's what that is. And let me show you what I'm talking about just in case, because this gets everybody. Oops. Let's go back to me. So in the drawing, there's a little, let's see if I can get it right there. There's like a little wire. It looks like they're actually touching, but if you look real carefully, it's kind of jumping over it. So that gets a lot of people in the labs. So just a helpful hint there. All right. Nope. I always do that. There we go. All right. And so now our motor's hooked up. Let me get back it so everything's, I can see all the gauges. We're going to go and power this thing up. And I'll make sure to turn all the knobs back to where they were. We'll close our switches, or open this switch here, turn this all the way down so we get it in a starting position. And then we're going to turn our power on. So everything's going to start running. So let me see where it says build 28.4. That's going to be on number 2. Okay, number 7. Page 234, number 7. Connect the circuit shown in 28.4. All right. Adjust the shunt field rheostat control knob located on the direct current machine module to a full counterclockwise position. So we did that already. That's this guy right here. Turn on the power supply and close S1 for the synchronous machine. So we did that. We're going to do that. There we go. And set up the prime mover for 1800 RPMs. Well, when we lock that in, it's pretty much 1800, so we're good shape there. Oop, it looks like I got these two backwards. Let me fix that so we get positive numbers. There we go. And what else we got? Okay. Adjust the control knob. This is number 10. Adjust the control knob on the front of the synchronous machine module until the AC ammeters indicate the lowest current. All right, so I'm going to turn this knob right here on the AC motor, AC machine, until I start seeing these things drop down. 0.2, 0.1, 0.9. So I'm actually adjusting the current until I see it start going back up. Okay, right there. So my lowest point was right there. So 0.17 is as low as we can get it. All right, so we know that's running. That's so now everything is it's set up and right. 1800 RPMs. Current's pulling the lowest amount. We're going to adjust the shunt field rheostat located on the front of the direct current machine, the DC machine, to produce 120 volts. So that's this guy right here. We're going to go ahead and turn him up and see if we can produce 120 volts. And that should be measured by, yep, the load up there. Oh, I got to turn these resistors off. I forgot that. Trying to get it to move it. It keeps snapping back. That one. Come on. I'm trying to turn these two switches off here so I can get to reset. And it's not letting me. There we go. I just had to get that meter out of the way. All right. So I'll put it right there. So that should be there. So our voltage is hooked up here. We're still in synchronous mode. All right. So everything should be good to this point. All right, so adjust the shunt rheostat on the DC machine until we get 120 volts. So I don't see, we're not producing any voltage yet. All right, why is that? Okay, ammeter's hooked up. Oh, you know why? I missed that one. That was my bad. All right, so the one I told you to jump over, I didn't hook that up. That was me. Okay. So that will go from the bottom of the resistor bank to number 2. There. Okay. I was like, why am I not getting voltage? Now we know. Operator error. Okay. So now we are producing 3 volts. Let me go ahead and turn this knob, and hopefully there it goes. Okay. Uh-oh. Motor shut off. All right, so motor's back up again. I don't know why it shut off. We got point. All right, let's get that back to its lowest point again. I'm going to turn the rheostat. Oh, we got to turn the S1 switch back on because I had to close it. And then let's get this back down to its lowest point, which we know was 170 right there. All right, so now we're back running again. I don't know what happened. All right, I'm going to turn this knob here until we are creating voltage right here at the 20 versus 27. So I want 120 volts. There it goes. I'm trying to figure out why it's not moving. So I turn that up. 60, 70, 80, 90. 120, right? Around there, right? Close. Try to get a little closer if I can, because I'm going to throw numbers off any. There you go. All right, 120.1. So that's this meter. Oops, this meter right here. I'm looking at. So that now this generator is now producing 120, and it is self-excited. So there's no separate power source powering anything. It's powering itself up. Okay, now that we're doing that, that takes care of number.
No, 12.
12, thank you. Yep, there it is. Fill in the chart. So we're going to do the same thing again. So the first one is going to be infinity, which we are now. And output voltage is 120. We knew that. Output current is going to be currently 0 because there's no path, there's no flow, everything's open. And the motor is at 0.272. All right, for 1200, we'll do the same thing. I'm going to close 1200, or yeah, close 1200. Now we're producing 116.6 volts. That is going to be output current of, we're looking at 0.097. And make sure yep, that's right. 0.097 is our output. Now this one has a field current, and that's going to be this yellow meter, and that's 0.250. And the last one is going to be AC amps, and that's going to be the 0.301. I missed that third one in the beginning. Let me go back and do the infinity real quick. Turn that off. All right, so the output voltage for this is the first one, infinity. Infinity was 120.1. Output current is 0. Output field current is 0.257. And AC amps is 272. All right, and then 1200. I'm going to do it again because I just skipped over it. I forgot the field current.
Oh, can you
Yes.
Can you show the last one, the infinity again, please?
Sure.
I put it wrong over here.
Okay. This is for infinity.
Wait. Let me copy. I copied the wrong place. Okay. Let's see. 0. 120.
So 120 volts. Yep. Output current is 0.
And the other one is
The field current is 0.257.
And
And
the other one is
motor is 0.272.
272. Thank
You're welcome. You see where these, when I start labeling these things, where they come in handy? It really saves your getting confused later. I know it does me. All right, so let's do the 1200. So this is 1200 ohms. Voltage is 116.6. The output current is 0.097. Field current is 0.250. And the AC amps for the motor is 0.301. All right, the next is 600. So that is going to be just the 600. So let me open the 12, close the 6. All right, so now we are pushing at 113 volts. Output current of 0.188. A field current of 0.242. And the AC amps of 0.326. All right, the 400 will be the 12 and the 6 closed together on the first module here. And our output voltage is 109.2. The current is 0.273. The field current is 0.234. And our motor is pulling 0.347. All right, let's get to 300 ohms. So I'm going to close these and open or close the 300, open the other ones. We're at 105.3 volts. So 105.3. We're at a current of 0.351, a field current of 0.226, and a motor is pulling at 0.364. All right, so that is the 300. So next the 240. So 240 is going to be the 12 and the 3. So I'm going to close the 12. Voltage is 101.4. The current is 0.422. The field current is 0.217. And the AC amps is going to be 0.378. All right, so now we're to the 150. So that's all three closed, the 12, the 6, and the 3. And then we're also the 12 from the second set. We are going to have 89.59 volts. The current will be 0.597. Field current is 0.192. And our AC amps is 0.396. All right, that is 240. So the next one is going to be 150. 150 is going to have all of the ones, 12. We just did 150, didn't we? Yes, we did.
You did already 150. Now it's 100.
100. Yep. Thank you. So 100 is going to be the 300. So I'm going to close all of these, or open all of these. When you put it up, you're closing the circuit. That's why I keep... There we go. So now we are at 100 ohms. Our voltage is 65.91. Our current is 0.659. Our field current is 0.141. And our AC amps is 0.340. All right, number 80 is going to be, see, all closed. So 12, the 6, and the 3, and the 12, the 6, and the 3, and then the 12. Okay, our voltage is 40, very erratic now, so we'll say 50.71, kind of stabilize there. 50.71 is the volts. Our current is 0.634, field current is 0.108, and our AC amps is 0.290. And then our last one, we'll close everything. All right, we're producing 30, let it calm down here, 33.03 volts. 0.578 is our current. Our field current is 0.070, and our AC motor is 0.236. So the whole point of that lab is to show you that a self-excited motor, the more load you add, the more it pulls down the voltage. So you saw that as we added more, as we reduced resistance as we went down the line, we were it was becoming less and less efficient. We weren't passing the same amount of current through as we were at the beginning. So we're basically we're pulling the system down. So this is called a self-excited, versus the last one was a separately excited, and it was a very, very constant. The voltage stayed about the same. So, all right. Do you want to do the 29 and 30, or do you want to do them on your own? As I'm just asking, because it's now 8:30, and I'm not sure if you want to keep listening to me going through these labs, or is it helping, or do you want to just kind of do it on your own?
Do you think you could do it so it could be in the recording?
Yeah.
And we could look back to it?
Sure. Okay.
Thank you.
Oh, no problem. I just want to make sure I'm not just, I don't want to make sure I'm just doing this for no reason. All right, so 29, exercise 29 is going to be the same thing. Again, we're not disconnecting. And that's a lot of these labs. Make sure you don't disconnect before you look ahead, because it might be the same setup. All right, so this one here is a compound. So we're going to go ahead and turn this motor off. We're going to open our switches up. We're going to turn our knobs back to the original positions. Once it lets me, there we go. I'm going to stop the motor. There we go. All right, so I'm going to do my connection here. Everything should be the same, but we're going to use both series and shunt. So I'm going to always start at the 2 here. So the 2 is going to leave and go to 8, which it does. 8 is then going to leave and go to the load. So that's where this has changed. So this will be here now, like that. Okay. So that's there. The voltage stays the same. The current stays the same. All right, so let's check on 1. 1. All right, so that will go to 3. I'll shorten that wire up, so kind of clean things up here. So this will go from 1 to 3, and this will jump from 4 to 5. I'll make that the same color. And then we don't need this guy here anymore for this particular one. So he needs to be, so he's on top, measuring current. So he's bound 5 now. So I need to disconnect him. Let me put him away for a second. Take all this all the way down to 5. Put this guy back where he was. Shorten that back up. And then do this. There we go. So it snapped back. There we go. So he was on 1. Or yeah, he was on the 1, and I moved him down all the way to number 5. So, all right. So everything else looks exactly the same. And my tip is always do your voltmeters last. We never took the voltmeter off; it's still sitting here. But always do that last. And I would start at a point, like pick 2, and just follow your path. So if you follow it through, it says 2 goes to 8. 8 jumps up and goes to the load. 8 also goes to the ammeter. Or sorry, 7 goes to the ammeter, just like last time. Then this goes to 6. 5 will go to the other ammeter, but it also goes to 4, and then 3 to 1, and everything else the same. So this is called a compound. We're using the series and the shunts now. All right, let's fire it up. Motor's on. Let it get to speed. All right, let me turn on the exciter. I'm going to turn my exciter knob until I get my lowest reading. So point, looks like 8.1 is the lowest I can get. 817. So 0.817 is my lowest current for my motor, my drive. Oh, I gotta open all my switches up. It's gonna change everything. There we go. Okay. Let me see if that's still the lowest. Okay, it's 0.7, 0.6, 0.69 it looks like. Yep. So 0.169 is the lowest I can get now. I messed up by not opening all those circuits. All right. So everything else will be same. Closed S1, we're at 1800 RPMs. This is number 7. Number 8 is the synchronous machine. Turn the control knob. We did that. So it's same things over and over as the last labs. It's always good to do them in order like that. Adjust the rheostat to get 120 volts output. So again, I'll grab this guy here. There he goes. And I'll turn up until I get 120 volts on my output. Oh, too much. Try to get right on, there we go, 120.01. All right, so I basically turn this knob here to get this number here to 120. So we're producing 120. Okay. So now we do it again. So we get my page open for my chart because I don't remember these things or memorize these charts. But it's you can also do the math. You can do the reciprocal method, but it would take forever. So we're going to use the chart. Okay, infinity. We're going to start at the beginning. The infinity is going to be voltage of 120, where output current is 0 because there's no path. Field current is 0.328, and the AC amps is 0.264. All right, so we're going to do 1200 with the first one. All right, kind of let it stabilize here. All right, so we're looking at 122.5 volts. We have a current of 0.102, and we have a field current of 0.243, and the motor is pulling 0.307. All right, so next one is 600. So let me open the 12, close the 6. All right, let's stabilize. We're at 124.3 volts. Sorry, 124.3. We have a current of 0.207. We have a field current of 0.246. We have the motor is pulling 3.53 amps. 0.353. All right, so the next one is 400. So that's the 6 and the 12. All right, it stabilizes here. We're at 125.5 volts. We have a current of 0.313. We have the field current of 0.249, and the motor is pulling 0.401. All right, next one is 3, so I'm going to open these two up and close the 3. All right, this will be stabilized right there. Okay, 126.4 volts, 0.421 amps. The field current is 0.250, and the motor is pulling 0.450. All right, 240. Now I gotta start looking. The 12 and the 3, so it's 12 and 3. So once it stabilizes, 127 volts, a current of 0.529, the field current of 0.252, and the motor is pulling 0.501. Okay, and just go to 150. 150 is going to be all of the first one and the 1200. Okay. So we'll close all these and then just the 1200. All right. So it looks like I got 127.2 volts. We got 0.848 amps, field current of 0.252, and the motor is pulling 0.656. All right, so now we're down to the 100. So that's going to be the 300, 300, and 300. So we're going to open these, open that one, and then 300, 300, and 300. So we're now making 125 volts. We have 1.250 amps, field current of 0.248, and then the motor is pulling 0.865. All right, and we're at 80. So 80 is going to be all of them on the first, all of them on the second, and the last one is going to be just the 1200. Okay, our volts are going to be 122.5, current of 1.532, our field current of 0.243, and our motors are pulling 1.022. The motor's working harder now, so it has to pull more current. Okay, and the last one, 66.7. Oh, that's a misprint. Should be 50. No, that's right. 66.7. Okay. So all of the first, all of the second, and then just the 300. All right, and that is going to be 119.6 volts, 1.795 amps, 0.237 is field current, 1.177 is the motor. And that will take care of that one.
The voltage dropped, went up and dropped. Is that right?
Yep, that's right. Because we're overcompensating and undercompensating the series winding, basically. So we're putting more of a load on it. We're giving it we're weakening and strengthening that magnetic field. So it's either producing more or less flux, meaning that it's not cutting as much flux, which means it's not producing as much voltage. So that the changing of resistance like that is allowing us to adjust how much is actually going through the field. So we're almost like we're at one point we're starving it out, and the other point we're actually giving it so much it's actually overproducing. It's producing more than we put into it. So we've only put 120 volts into it, but it was producing 122, 123 at one point because we were over compounding. So that's right. Yep, those numbers are pretty straight on. Okay, and then I'm looking to the next one here. All right, so does that fill the chart out? Open all the switches. Turn off power. Close switch. Okay, so we'll get everything reset, and then we'll get ready for the next one. But we know better than to tear it down because that just causes more work. There we go. We're going to turn the power off, and we're going to tilt to stop the motor. Okay. Now it says that it wants us to reconnect the circuit in 29.8. But let me check and see if we have this three-phase rheostat because I can't remember if we actually had this in our inventory. Let's check. Because if we don't, we're not doing it. And the same thing, if you can't find the module, we'll just skip over things that we don't have. I mean, definitely check with me first just in case you don't see it. But all right, so this should be, let me check the beginning of the chapter and see if I can find the number for it.
8731. We don't have
We don't have it?
8731. We don't
Okay,
have.
no, we don't have that one.
We jump from 86 some to 88 some.
Yep. Okay. Well, yeah, we can't do that one. We will skip over that one. And what this is doing, this is acting. A rheostat is a variable load. So what you would see this here, you would actually see it pulling down the current going through the field or the windings, and doing that overcompensation, undercompensation we talked about earlier. So, okay, that takes care of that one. All right. So now we're on to 30. We're knocking these things out. Look at that. All right, so it looks like everything's exactly the same. Let's check our motor out, make sure our connections are the same. Let me close my inventory box here. All right, we're going to leave the number 2. We're going to go down to 8. 8 is going to go to the load, which it is. Put that back where it was. Also going to, we're going to go to 7. 7 goes to the meter. Meter comes back down to 6. We leave 5. 5 goes through the ammeter to the load. That's right. We're measuring voltage. And 5 goes to 4. Oh, they have 5 going to 3. I don't see what that would matter, but let's do it. Let's do what they did. So I'll take 5 and go to 3. Let me shorten that up.
Which number you talk about?
This is on figure 30-3 on page 252.
Okay.
They changed the before it went from 5 to 6. Oh, I see why. Yeah. Okay, never mind. They went from 5 to 6 to from 5 to 4. Now they're going from 5 to 3. So everything's exactly the same. They just basically reverse the current on that one winding there, and you'll see why it does act different. Okay, and everything else is the same. So the only thing we changed was literally took that wire off from 5 to 6 and went to 5 to 3. I mean, sorry, 5 to 4. It was 5 to 4, and now it's 5 to 3, and then 4 to 1. It's only change in the whole thing. Everything else is exactly the same. All right, so this is the differential compound DC generator chapter or section lab. All right, so let's read through it. Synchronous motor, blah, 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 blah. 5. Adjust the rheostat. Okay. All right, so let's make sure everything's turned off. Let's open our loads again. I'm just kind of skimming through the wording, but it's basically the same thing, the startup procedure. Everything's turned off. Everything's counterclockwise. Okay, we're at a starting position. It says it's number 7, connect the circuit in 30-3, turn on the power supply and close S1. So power supply on, kind of let it get up to speed. All right, we're going to close S1, and then we're going to adjust the meter until the AC levels off, just like before. So 0.16, yep, same thing, 0.169. All right, so now that is ready. We're going to turn our rheostat here until we get to 120. So we're going to crank that up until we get to 120. Super sensitive. There he goes. 120. I'm gonna try your trick. I'm gonna go a little farther away.
Yeah.
There it goes. There we go. 120.1. All right. Let's do this again. This will be the last one for tonight, and then we'll call it a night after this one. All right. So the first one is infinity. We're producing 120 volts, 120.1. We have no current, and our field is at 0.284. Our motor is pulling at 0.281. All right, so we're going to do the 1200 ohms. 1200 ohms will bring us all the way down. See how much that really pulled that down to 105.5 volts. We have 0.087 for the current. 0.249 is for our field current. 0.283 is going to be the motor. All right, let's go 600. 600 ohms. See, it pulled down a whole bunch more. We're down at 89.43 volts. 0.149 amps. We have a field of 0.211. We have the motor is at 0.269. All right, next one is 400. So that's the 12 and the 6. All right, now we pulled all the way down to, okay, we got 66.63 volts. We have 0.166 amps. The field is at 0.157, and our motor is pulling at 0.233. All right, now we're at 300. So I'm going to open these and close the 3. All right, we're at 65.13 volts, 0.217 of amps. 0.154 is the field, and 0.242 is what the motor is pulling. All right, we're gonna now the next one is going to be 240. So 240 is the 12 and the 3. All right, so 12 and 3 is going to bring us all the way down to 50, still dropping, 49.78 volts. We are going to have a current of 0.207, field of 0.117, and the motor is at 0.215. All right, we're down to 150. 150 is going to be all of the first, and oops, and the 1200 for the second. Is that right? Yep. We are at 27.25 volts. Really pulled down the voltage. We have at 0.181 is our current. Our field is at 0.064, and our motor is at 0.182. All right, the next one is going to be down to 100. So that'll be 300, 300, and 300. Okay. We're 18.93 volts. We are at 0.189 on the current. We're at 0.044 on the field current, and then our motor is at 0.169. Okay, and 80. This one's 80. So we got these. And the 1200. All right. So here we have 14.57 volts, a current of 0.182, a field current of 0.034, and a motor current of 0.169. All right. So last one, 57.1, so that's everybody. Turn all those on. And now we are producing 9.894 with a current of 0.173, a field current of 0.023, and then the motor is pulling 0.169. And that is all of them. Did that help a little bit with all the labs? I mean, I'm really hoping that seeing them and going through them is kind of made a little bit of a difference as far as not take the confusion down a little bit. Did that help a little bit?
Yeah. For me, it did. I just kind of got lost in one of the last two labs because I messed up in one of them and I just got lost completely after that.
It's okay.
So.
It's all good. Yeah, we'll you just watch the thing and hopefully catch back up with the video.
Yep.
Because I didn't write it down. I was like, give you the answers. I was reading them as fast as I was putting them out. Yeah. Okay. That's good. I'm glad it's helping. I'm glad it's at least making sense now. So moving forward, what we're gonna do is next week when you see me, we're gonna do a lesson, and then after that, whatever time we have left, we'll do a lab, and then that'll be the DC motors labs, and we'll start those labs, and then the next week is no lesson, but we'll continue on with the labs. So basically, every section is gonna have 2 weeks attached to it. And then we're going to get to the review section. So after DC motor, we should go into review, and then midterm, and then spring break, and then we're just going to be like a few weeks in a row of no new stuff. It's just learning and all that stuff. And then we'll come back and do AC motors, AC 3-phase motor, or AC alternators, and then AC motors, and then single phase motors, and then we'll go back into review, and then we'll go into for finals. So basically, I'm going to try to get more, now that I kind of see the strengths and weaknesses of the program, what I'm going to try to do is I'll get everything fixed on the Canvas stuff, and then I'll get it up to you guys, because everything, like I said, everything's built, but it just wasn't working for what we're doing. For some reason, I don't know. But now where people are getting the books in, and people are understanding the software a little more, and I think we're starting to get to that thing. So, but again, it's always up for tweaking and stuff. So let me know if anything you see could be improved or whatever. Just let me know, and I'll be happy to make those adjustments. There's certain curriculum I have to hit, so I can't just like throw things out. But we definitely got to make sure that we are hitting our milestones. But besides that, we're gonna have fun with it. And I said, 2 weeks per thing. So this will be the second week of DC generators. We'll go to DC motors next, and do 2 weeks of that. And you guys are done with all the labs now, so you're good there. Just make sure to do all the review questions from 24 to 30. When I get that module opened, go ahead and attach all of the review questions to the review question module, not the module, sorry, the review question assignment, and then you're going to see one that has the lab assignment. That's the saving of all these. Build these, save it, build it, save it, build it, save it. Take all those files and then send them to me. So
You don't want us to make the graphics, right?
What's that?
The graphics.
You don't have to send me the graph. No.
Okay.
No. But if you do the graph, if you wrote those numbers down and you actually do the graph, you can see where the motor gets stronger or the generator gets stronger than when it drops off. You can see how they behave. So undercompounded, overcompounded, self-excited, separately excited. You get to see all these different versions, and you kind of see as you add resistance and take this resistance away, you can see what happens.
Okay.
So that's what the graph is for, and so you can visually see where it kind of falls apart.
Okay.
But yeah, I don't need those. That's for you. That's for you. So just build your circuits, save them, build all of them. Also, every time you see an assignment where it says, please construct, or it says connect the circuit shown in figure 30-3, right? So I just need 30-3 built, and then saved, and then sent to me. That's your lab portion, so I can see you're doing it. And the review questions will be on another assignment. You'll see it say review questions, and that'll be that one there. There will also be coming up the practice problems and review questions from the actual textbook. So the textbook itself will have its own set of review questions. Still haven't decided how many to put out there yet, because again, we have a lot of work here. So I may just live here for a while on the lab, and then DC generators, I might just go ahead and throw some back in there, but we'll see. But I don't believe at this point I'm going to add anything else. I think the labs are as far as I'm going to go with this section, because people are just really getting caught up, and that's fine. That's good. That's as long as we all get up to catch up together and we all end at the same finish line, we're good. So, is there any questions I can kind of fill in the blanks or whatever? If you email me and I haven't got your email, I will get to you. If you turned your homework in or turned stuff in via email, it's not my recommended choice, but because I haven't had things up, I completely understand, and I'll take all that stuff and put your grade in. But once the module's up, just put them in the Canvas, please. But if you've already submitted it, then you're good to go. And yeah, and besides that, I will see you guys next Wednesday. So.
You said review questions.
All right.
Yep. What I had a question about review questions.
Yeah, what to what?
Oh, exercise 24 through exercise 30.
24.
So you want all those labs turned in?
Yes, please. Well, the first ones we did, the real simple ones, no. The only one that actually started getting built was on what section was that? 24, 25. So 27, I think 27.4, I think was the actual first one that we actually started constructing as this thing. Before it was just a single loop or single circuit. I don't need those. Yeah, so 27, and then the labs in between. So it should be a lab for 27, a lab for 28, and so on. The only one we're going to skip over is the one that has that variable resistor module on page 244. We don't have that, or it's the schematics on page 243. Figure 29.8. Don't do that one. We just don't have it. So on this unit, we have it at school, but I don't know why it's not on here. But we can't do it, so it's all good. All right, so yeah, so you guys have all your labs are done, and yeah, just turn that stuff in. I'll get the modules up for you, and yeah, besides that, I will see you guys next week. Again, if you have any questions, please let me know, and I'll be I'll get the videos up. I'll get the all the stuff online. You're gonna start seeing things start to pop up. So don't stress out about it. But I'm not gonna. You start seeing work. It's not like more work. I'm just putting what I should have done already. If things hadn't fallen apart like they did, but it's all good. So, all right, guys, I'll see you on Wednesday.
Okay.
See ya.
All right, take care.
Thank you for everything. Have a good night.
You're welcome.
So when do we? What's the last lab we turn? It starts at 27-4 until unit 30 or exercise 30.
Exercise 30. Yep, that'd be the last one for this unit. Yep. So
all the labs in between 27-4 and 30.
yes. Yep.
Okay. Thank you.
You're very welcome. Garland, you good? Any questions or anything?
No. Have a good night.
Oh, you too. Okay.